This is the third video in the 4.2a lesson, Review of Inequalities. We're on the last page of the lesson. Please follow along as I go through a couple of these examples, and I'm going to let you try some of them. It says, for each problem below, graph both statements on the same number line. What integer values for x make both statements true at the same time? So at number 20, we have two inequalities. It says and, so we're looking for something that works for both of these. So we're going to graph each one. We're going to color code it. So the first one I'm going to do in pink. It says x is greater than 3, so I'm going to put an open circle at 3, and I'm going to go to the right. My second inequality, I'm going to use green, and it says x is less than or equal to 7, so I'm going to put a filled in circle at 7, and I'm going to go to the left. I'm going to look for, notice I tried to see where pink and green match up. And so what I'm noticing is that the and, or the part that overlaps or that works for both of them, is right in the middle. And so it says what integer values. So my integer values are going to be, well, 3 doesn't work because it's open. I'm looking for values that work for both of them, so that are in between here. So 4 is an integer, 5 is, 6 is, and does 7 work? Well, yeah, it's shaded, it's filled in, and 7 works. The other thing I'm going to do is I'm going to write an inequality that represents this. If you remember at the start of the lesson, we saw an inequality where x was kind of sandwiched or smushed between two inequalities. And that's what I'm going to do here. So what we see is that 3 is less than x, so that was the left boundary point, which is not shaded. And the right boundary point was 7, and that was shaded, so we're put less than or equal to 7. And so this inequality represents where these graphs overlap. Let's look at another example. I'm going to skip down, and we're going to look at number 23, because this one has something a little unique. You'll notice, if you remember from the other video, that you want x on the left side. So the first thing we're going to do is we're going to rewrite this so that we don't mess this up. And then I'm going to graph them, and again I'm going to color code them. So I'm going to graph this first one in pink. X is greater than or equal to -3. And I'll do the other one in green, which is x is less than 7, so open circle and shaded to the left. I'm looking for where these two colors overlap. And so I see that they overlap in the middle again. And so the set of numbers that are integers, no fractions or decimals, that are going to work is -3. This boundary point's filled in, so I'm including it. -2, -1, 0, 1, 2, 3, 4, 5, 6. I'm going to stop there though. 7 is open, so we're not going to include it. And then we're going to create our inequality that is sort of that sandwich or smush. And the smaller value was -3, and we included that. And the larger value was 7, and we did not include that. So we have this inequality: -3 is less than or equal to x is less than 7. I'm going to do one more with you, and then I'll give you some time to try the other one. So let's look at 24. We'll do the same thing that we've been doing. We notice that x is on the left on both of these, so we'll just start graphing them. So x is less than -5, open circle, shaded to the left. X is greater than or equal to 4, filled in circle, to the right, and we're looking for where these overlap. We actually see that there is no overlap. So that actually means that there's nothing that's going to work. So when it says list the integer values, there aren't any. And so what we're going to do is we're going to write no value will make both statements true at the same time. So what I mean by that is 7 works for the green one, but it doesn't work for the pink one. So then if I try to pick something that works for the pink one, like -8, well, that doesn't work for the green one. So there's nothing that's going to work for both of these. At this point, go ahead and pause the video, fill out all of the ones I skipped over, 21, 22, and 25, and then unpause the video and compare your answers. Okay, hopefully you had a second to compare or to try those, so we're going to now compare answers. So you tried number 21, and when there was the graph, we're looking for the overlap. In the overlap, the integers were -2, -1, and 0. And the combined inequality is -2 is less than or equal to x is less than 1. Number 22 was a trick question. When you graphed each one, there was no overlap, so we just wrote the same thing we wrote on 24. There's no value that will make both statements true at the same time. And the last one, hopefully you rewrote the first inequality for number 25. And notice that both of them are open circles. So we did not include the endpoints. We went -2, -1, 0, 1, 2, 3. And then the inequality that explains this set of numbers that would work for both of the original inequalities is -3 is less than x is less than 4. So that was the rest of the 4.2a lesson, which is a review of inequalities.